Greetings to everyone. I am Dr. Reena, Assistant Professor of Mathematics at Norris College at Thoothukudi. In this session, we are going to discuss the concepts of canonical and standard forms of the L.P.P. Before get into the session, we will recall what is L.P.P. A linear programming problem consists of three components, namely objective function, constraints, and non-negative restrictions. A general form of the linear programming problem is maximize z or minimize z is equal to c1x1 plus c2x2 plus etc. cnxn, subject to the constraints a11x1 plus a12x2 plus etc. a1nxn less than or equal to or greater than or equal to b1, a21x1 plus a22x2 plus etc. a2nxn less than or equal to or greater than or equal to b2, etc. and so on. am1x1 plus am2x2 plus etc. amnxn less than or equal to or greater than or equal to bm, and x1, x2, etc. xn greater than or equal to 0. The linear function z is equal to c1x1 plus c2x2 plus etc. cnxn, which is to be maximized or minimized, is called objective function. The set of inequations in B are called constraints, and the inequations in C are called non-negative restrictions of the L.P.P. Now we will move to the concepts of characteristics of canonical and standard forms of the L.P.P. For canonical form, the objective function is of the maximization type. All the constraints are of the less than or equal to type. All the variables are non-negative. Consider the following example. Maximize z is equal to 3x1 plus 2x2 plus 5x3, subject to the constraints 2x1 minus 3x2 less than or equal to 3, x1 plus 2x2 plus 3x3 less than or equal to 5, 3x1 plus 2x3 less than or equal to 2, x1 greater than or equal to 0, x2 and x3 greater than or equal to 0. In this example, the objective function is in maximization type and all the constraints are of in the less than or equal to type, and the variables, that is x1, x2 and x3, are greater than or equal to 0. Therefore, the given L.P.P is in the canonical form. Likewise, for standard form, the objective function is either in maximization type or minimization type. All the constraints are expressed in the form of equations. The right hand side of each constraint equation is non-negative. Consider the following example. Minimize z is equal to 3x1 plus 2x2 plus 5x3, subject to the constraints 7x1 minus 5x2 equal to 3, 2x1 plus 5x2 plus x3 equal to 5, minus 3x1 plus 2x3 equal to 2. x1, x2, and x3 greater than or equal to 0. In this example, the objective function is in minimization type and all the constraints are in the equation form, and the right hand side of the each constraint equation is non-negative. Therefore, the given example is in a standard form. If you are asked to solve a L.P.P, first we should convert the given L.P.P into standard form. To convert the given L.P.P into standard form, we should know what is slack variables and surplus variables. Definition of slack variables. Consider our general L.P.P, summation j is equal to 1 to n, aij xj less than or equal to bi. Then the non-negative variables xn plus I, which satisfy summation j is equal to 1 to n aij xj plus xn plus I equal to bi are called slack variables. For understanding this concept, let us consider a small example. We know that 2 is less than or equal to 5. To convert this less than or equal to into equal to, we just add 3 with 2. That is 2 plus 3 equal to 5. This 3 is known as the slack variable. Definition of surplus variables. Consider our general L.P.P, summation j is equal to 1 to n, aij xj greater than or equal to bi. Then the non-negative variables x n plus I, which is satisfied, summation j is equal to 1 to n, aij xj minus x n plus I equal to bi are called surplus variables. To understand this definition, let us consider a simple example. We know that 7 is less than or equal to 5. To convert this greater than or equal to inequality into equal to, we should subtract 2 from 7. That is 7 minus 2 equal to 5. This 2 is known as the surplus variable. Therefore, if we are asked to solve a L.P.P, first we should convert the given L.P.P into standard form. We can convert the L.P.P into standard form by introducing either slack variables or surplus variables. If the constraints are n less than or equal to type, introduce slack variables. If the constraints are n greater than or equal to type, introduce surplus variables. Now let us see an example. Convert the following L.P.P into standard form. Maximum z is equal to x1 minus 3x2 subject to the constraints minus x1 plus 2x2 less than or equal to 15, x1 plus 3x2 greater than or equal to 10, x1 and x2 greater than or equal to 0. In the first constraints, we have less than or equal to inequality. So we introduce a slack variable x3. In the second constraint, we have a greater than or equal to inequality. So we introduce a surplus variable. Therefore, the constraint will become as minus x1 plus 2x2 plus x3 plus 0x4 equal to 15, x1 plus 3x2 plus 0x3 minus x4 equal to 10. The cost of the slack variable and the surplus variable is 0. Therefore, the objective function is maximize z is equal to x1 minus 3x2 plus 0x1 plus 0x4. Here I have given some learning materials for your reference. Hope you all understand the concepts of canonical and standard forms of the L.P.P. Thank you.